The Athletic.
In this episode, we talk Mercedes' latest update, which was taken off the car during the Spa weekend, and hear from Bell Helmet's CEO, Stephane Cohen, on the amazing developments in head protection. We also tackle your questions on engine development, engine failures, rear-view cameras, and crashes. Welcome to another episode of the Race F1 Tech Show. It may be the August break, but that doesn't mean the tech chat stops. As always, I'm Edd Straw, but far more significant is the fact I'm joined by Gary Anderson, who's made a big contribution to F1 technical history himself and still keeps a very keen interest in goings on. How's your summer shutdown going, Gary?
My summer shutdown, yeah. It's going well. It's one of those sort of situations. Obviously, the last two races, Hungary and Spa, showed that we have now more cars capable of winning. Obviously Austria as well, to be honest. If we take into account that Russell won with a little bit of help from a couple of non-friends, I suppose. But yeah, it's nice to see another team joining that fray. We've got Red Bull at least with one car, Ferrari, Mercedes, and McLaren all potentially in the mix. You could say on their day, but I think more consistently than on their day now. So that's great for the sport. That's great to see. I'd love to see another one join that club because the more competition you have at the front, the more the pressure changes, and it's not just a walk in the park on a Sunday afternoon if you got a few other cars biting at your heels. So the more competition, the more it's going to be. It's going to change the pressures, and the more fun we're going to have sitting watching it.
Yeah, it could be a cracking second half of the season on the current trajectory, so let's hope that it is. And as ever, we'll start off with a free choice of topic for you, Gary. So what's on your mind right now in terms of F1 tech?
Well, the main thing is car development. I'd like to sort of relate to, because obviously this is the summer break. It gives teams time to have a look at the data and really analyse it a bit and not have to make quick decisions because there's a race next week. And we have this 2-week compulsory shutdown for all team members as such, but that doesn't stop you taking a laptop home and having a little bit of a fiddle and a little bit of a look at stuff. But really it's a development, and there's two teams really, I suppose, at the minute that we're saying, there's more than two, but there's two teams that are sort of up there at the end of development where they're getting themselves a bit lost. The first one's Aston Martin, which I suppose you could say has lost itself in the last year and a half, really. It's one of those sort of things. They started 2023 very strongly, and then it fell away in the second half of the year. And they've never really come back as strong as they were at the beginning of 2023. 2023 they were looking like they could win a race or two. It didn't happen for them, and as I say, they dropped away a bit. And that sort of really has continued, as I say, into 2024. They're up and down a bit like a yo-yo, but they haven't got any consistency. And that's a problem because, it's all right having a good car, as they had, as I say, in the beginning of 2023, but you need to know why you got a good car. And you can make mistakes. It's important to make mistakes and learn from them and be able to step backwards and regroup. But if you continually make mistakes, then it just shows that you don't actually know what's making it work. Never mind not knowing what's making it not work, you don't actually know what's making it work to try and exploit that a bit further. And what we've seen really with this Mercedes new floor that they introduced and tried to use in Spa, they didn't, the first day, the Friday, wasn't really great for them. But it was, it was the first day at the track and all that sort of stuff. But the bouncing had come back more. The drivers' complaints were there. So they changed back to their old floor. And obviously they come out with a decent result. It could have been a very good result, but it wasn't to be in the end. And again, that shows a little bit to me. They've got themselves up front now. And they're racing at the front, and they've won races. But it still shows to me that they're still not on top of what actually makes it work. The thing about the underfloor is you can't keep exploiting more and more downforce out of it because it will bite you. It's the critical part of the floor. It's developing, 75% of the downforce that the car's got. And as we know, the front and rear wing, it doesn't have any major dramatic characteristics that makes it generate bouncing. They're just fairly stable things. So they're the other two parts that generate downforce on the car. So the underfloor for Spa, as far as I know, they exploited more load out of it. That's their words. By changing the turning vanes, the floor edge, the diffuser, various areas, to exploit more downforce out of that underfloor. And suddenly they've got the bouncing again. Now again, Spa is a high-speed circuit, so if you're going to have bouncing, it's a circuit where you would have that at. But it does show that their quest for downforce, to me, is still very evident. And what they're doing is not managing that downforce very well. Everybody wants more downforce in low and medium speed corners. I mean, the numbers of downforce that you have in a 100-kilometre corner is nothing like what you have in a 300-kilometre corner. But because of that, then, the load that you have on the tyres and on the suspension is also nothing. So what you want to do is try and create more downforce at low speed and not create more downforce at high speed, so the car doesn't get so near the ground and suffer from porpoising, airflow separation in the diffuser area or in the underfloor area. And I think they've put themselves back in that position again, and that sort of is a question mark that I would have as to their real understanding of what makes the car go quick. I think you have to have consistency from the underfloor, but you want to produce low speed downforce. And now McLaren, in my book, are a pretty good example of where they said they were a while back. The car was pretty good in high speed, but they didn't have the performance in the low speed corners. And they've been able to sort of regroup themselves to get the car to produce more downforce at low speed. And whenever we're talking about speed, we're talking about ride height here. So more downforce at high ride heights, which is actually low speed, but not to have more downforce at high speed, which is low ride heights. So that's the sort of area, that's the thing you want to be exploiting and understanding, because then if you can do that, you can move forward. There's no point just blindly, as I say, creating a few more points of downforce at 300 kilometres an hour, which leads to bouncing, which leads to the car being inconsistent, which leads to just the driver not liking it, because you won't go faster. You just want to get more grip at low speed. And so, as I say, that's like where Aston Martin have fallen foul. They've blindly been developing the car and changing lots and lots of bits, but I haven't seen them have the performance they had at the beginning of 2023. And I haven't seen them regroup from the middle of 2023 when they sort of went astray. They've got closer, but not in my book, not as close by any means to winning a race as they did at the beginning of that year. So for every team, it's difficult. But, the first thing you got to do is understand where the problems are generated from and just stay away from that.
To play devil's advocate on it, obviously Andrew Shovlin said, well, we think we understand why these problems happened. It was the way we were running the car, as you alluded to, some bouncing and balance problems, bouncing a little bit in the high speed, as is often the case, and they are working towards reintroduction at Zandvoort. So you could argue it was just a circumstantial thing, especially given it was going to be wet on Saturday. They said, well, the car was good at Silverstone, so we could revert. And you could also say the past few months of development show they've got a pretty good idea of where they're going. So I guess that's the sort of the Mercedes counter argument, but obviously it'll come out in the wash once the car starts running again, won't it?
Yeah, well, Zandvoort's a very, very different circuit from Spa and or Silverstone. So to relate a problem at Spa and try to use the same componentry at Zandvoort and see if it's better or worse is impossible. If, as they said, the car was good at Silverstone, why would you go to Spa with a different setup on the car? You might go to Spa with a aerodynamic package that generally creates, an extra 1 or 2% downforce, and that's a huge amount. But there's no reason to go to Spa with an underflow that will create 1 or 2% more downforce and a major setup change, because, as you say, Suzuka, Spa and Silverstone are two fairly similar circuits in their own little way. Spa's a bit faster on the straight, so you're running less wing, but you're not interfering with the mechanical setup, and you're not interfering with the underflow aerodynamic setup. If you've got a slightly better floor, then you run it, but you don't run it mechanically different or hugely different anyway. So interesting that they made that statement. But as I say, from my point of view, and they'll say the same. Talk's cheap. I'm only talking, but so's Andrew Shovlin. So let's see what happens in Zandvoort. I'm sure they'll be up there and they'll be competitive because they've got the bit between their teeth now. But I would say what I'm really sort of trying to suggest is that they need to look deeply at why that porpoising came back, because they need to stay away from that area of development that they did for the future, because otherwise they're going to end up digging a hole for themselves again.
The fascinating thing is how three-dimensional this upgrade challenge is, because if you go back in the day, if you were going to stick an aero upgrade on a Jordan, if it was well conceived, if it was nice and consistent and usable and worked as you expected, you could put it on the car, more downforce, and it's going to work. Whereas now you have to be really sure-footed because it's so easy to pile into problems and sometimes even promote problems that are already there. For example, with Ferrari, the porpoising problem it's had since that Spain upgrade, that porpoising was there before. It just wasn't such a big problem. And you take another step down the line and you promote a problem that's sort of just the right side of the line to one that's the wrong side of the line. It does feel that with these cars, it's massively easy to send yourself just a little bit too far in the wrong direction and get yourself in all sorts of trouble just by the introduction of the ground as such a key driver.
Yeah, I agree with you to some extent. I mean, let's put it like this: it was never easy. But what you have to
I was a bit reductive there.
What you have to do is read between the lines a little bit. It's more dramatic now, let's say, than it used to be. But I would have to say that during the period of the high downforce, lower front wings, we've seen cars porpoising because of that. That's just ground effect. And even the flat bottom cars, we did still have problems. And the biggest thing was if you had a problem, let's say testing in Barcelona when it was 15 degrees ambient on a good day and the track temperature was 25 or 30, and you went back there when it was 30 degrees ambient and track temperature 50, you just exaggerated those problems dramatically. And nowadays, because of the ground effect, that's even more critical. The ground temperature and the ambient temperature has such a big influence on aerodynamic production from any aerodynamic surface, but especially working in conjunction with the ground. It just is a completely different problem. And we hear this, always this complaints about, our car's better when it's cooler or our car's better when it's hotter. It's because it's suited to those conditions that little bit better. So at the end of the day, it's very, very difficult to have a car that's good in cool conditions and good in hot conditions. If you've got an aerodynamic surface that's running, a bit critical at a certain given temperature, as it gets hotter, that problem becomes more and more and more. So, you've got to be very, very careful with all that stuff. But it was never easy. It's just one of those sort of situations now because we call these ground effect cars and they're developing so much more of the downforce from the underfloor. It's become a bigger problem, but the problem was always there, just to a lesser degree.
Yeah, absolutely. Like you say, never easy to do, but it is a very, very interesting phase of the development curve for these cars in terms of whether they're pushing up towards those diminishing returns. Are they pushing too hard with them? And I guess that's the big question everyone's going to be asking themselves, isn't it? How far they can reliably push, because they're at a point now where if you can get even a 10th swing in your favour, that can make all the difference. So try to balance up that natural desire, the greed for the extra performance with are we overreaching? And maybe that's even summed up by the Red Bull peaky but probably faster when it's working car against the more all-round car for all seasons that McLaren have got.
Yeah, so there's a difficult thing, this diminishing return part. I feel a little bit, and I'm not knocking Mercedes here, please don't get me, don't think that. But what I'm saying really is that they've been on a fairly decent trajectory as far as recovery is concerned. And there's a point in time whenever you got to sort of bite the bullet a little bit and not introduce big upgrades because you haven't got the best out of what you've got. And I think Spa did show that with them, whenever they went back to the old floor and a setup they understood. There was limited time to actually, get the best out of it. But if they'd gone to Spa with the old floor and a setup they understood and used the Friday to better it, they'd probably had a better car come Sunday night or come Sunday afternoon. It's easy to do that. I've been there myself. It's just, so easy to just keep firing bits on. and just creating that one more problem all the time.
Yeah, and that's going to become particularly critical in the second half of the year. Now we've got several cars that are within striking distance of winning, and Ferrari probably should be back at that level if their upcoming upgrade fixes the problems they've had, which of course is a big if. But yeah, it's going to be a great second half of the year. Well, we're going to hear from Bell Helmet's CEO Stephane Cohen shortly, but I think before we hear that interview, it's worth talking about the general helmet, driver's head, cockpit, halo area from a design perspective. Gary, how important is that area around the driver's head? Is it simpler these days now that drivers are much more enclosed rather than being sticking out in the way that they used to be? Or is it still a very critical part of the car?
No, it's still a very critical part of the car because it's, the given shape of the helmet is something that it's not aerodynamically, it's not the most flow. Aerodynamically, it's not the nicest shape of a thing to have, and try to get good flow around it. That's why you see the bodywork sort of, I suppose you might say, as an extension of the helmet. And I think if you go back to sort of bicycle racing, when they had a sort of long pod on the back of the helmet, that's a typical example of trying to improve the aerodynamics, because getting the flow around the helmet's never easy. I mean, one of the things that's happened over my time in Formula One, I suppose, is the changes of helmet. We used to have these, even two eyelets and a brace down the middle of it, very, very deep chin sections. So the helmet change has been through material technology, and also technology of impact absorption, foams inside the helmet. And that's allowed the helmet, I think, to get a little bit smaller, a little bit better shaped. And we still see, on the trailing edge of it, little trips to make sure that the helmet, the flow coming off the helmet, doesn't sort of give the driver too much turbulence. If you go back to Michael Schumacher in I think it was the 96 Ferrari, 97 Ferrari maybe, when he was driving along with his head out the side of it, really, because the airbox just didn't work, or the engine airbox just didn't work with the turbulence coming off the helmet. So it's been there for a long time, the problem. And that's why, again, you see the airbox intake as such separating a little bit from the top of the headrest to allow the flow to come off the top of the helmet and go through into an area where it's not creating turbulence inside the airbox. So yes, a lot of change in the helmet area, but I think still the same problem hangs in there. It's still very, very difficult to get flow around the helmet without introducing other parts of the bodywork to sort of enhance the flow around the helmet. It's different now because obviously with the side impact, the headrests and the rear headrest, the head movement has been reduced quite dramatically. So you don't get these big offsets in, like Jean Alesi used to drive along with his head hanging out the side of the cockpit, really, just because he could. So you don't get that so much now, so it's more defined. But there's designers around, very, very successful designers around it. The first thing they do with the driver positioning is define the position of the head, and the rest of the bodywork of the car around that area gets designed around that helmet design. So some of us that used to use pay drivers as such, or not know who the driver was going to be before the season started, didn't have that luxury. So you sort of get the differences in a very tall driver or a very small driver. And, trying to get the head in the same place is almost impossible. But, it's a big challenge in car design to optimise that area.
Were there any cases from your career that stood out as particularly challenging? I always know if you look at the 93 Jordan, for example, you'll see Thierry Boutsen kind of overlaps the air intake on the airbox, whereas Rubens Barrichello is below it. So that's an example that sprung to mind for me. But was here a particular problem from that perspective, and were there other drivers who were a big issue in terms of the way they basically got in the way of the air intake? Yeah,
I think whenever we look back, I think Justin Wilson was one of the tallest drivers. He drove the Jaguar after I was there, but he was one of the tallest drivers, so not easy to package. But what you got to remember is there is a minimum cockpit length on these cars, from the seat back to the pedals. Personally, I don't think it's quite long enough, but it's there. So it accommodates 95% of the drivers, whereas going back quite a few years, there was no length there. So basically, small drivers were a premium. If you could get a small driver, you could package your car better. The difference in Rubens and Terry Boutsen, for example, where Rubens was in the right place, and because you sort of knew that, you designed the car around that. But when somebody like Terry Boutsen comes in, or Ralph Furman, you have to make the best you can, and you can't do anything different. Terry Boutsen with the car, the first time he drove the car at Donington, I think he did a very commendable job because he just didn't fit the car. And post that race, we did a new seat back in that, and got him into a much, much more comfortable position. And from there on in, he never performed like he did at Donington. So why? I don't know. It's one of those sort of situations where you do the best you can for the drivers, but if you don't know your drivers you're going to have well before the season starts, then all you can do is you either make a big car. In those days, you either made a big car with plenty of space in it, or you went for the best package you felt was the right thing, and just then it was a compromise from there on in. So, like Eddie Irvine, Eddie's very, very different. He's got a long body and short legs, so he was always difficult with where the fire extinguisher used to sit down in front of your thighs, because his body was so long, and completely different packaging for that type of guy. But it wasn't really the weight of his wallet. I suppose it is now the weight of his wallet that's dragging him down a bit. But it's just one of those sort of situations. You have to make the best you can when you're trying to fit the driver in the car. If you know who it is, that's fine. If you don't know who it is, then you still have to do the best you can.
Do you ever have any dealings with drivers and helmet manufacturers to try and make modifications to help what you were doing?
Helmets were difficult to influence because obviously there's a huge amount of research goes into helmets. The introduction of the hands device was something that, became a sort of a topic of conversation at that time. None of the drivers ever wanted it, because they just felt it was encroaching upon their ability to move their head in the way they wanted to move their head. And the headrest again, that was seen as something that was restricting their head movement. So we, through time, we did influence the headrests, and we did influence the hands device, and it's a much smaller, lesser obtrusive device than it was originally, but it's of great value for driver safety, for helmet, for head restraint. So it's one of those things where I think everybody's bought into it now. And obviously that influenced the design of the area around the headrest quite a bit. But as far as the helmet itself is concerned, not really. We would have played around a little bit with some of the turning vanes and that you see on the back of the helmet, just from the flick ups and bits and pieces. But only because they were extra to the helmet. But as far as the helmets are concerned, they have very stringent tests. So you've got to let the helmet manufacturers do the best they can. I think the first thing, I think Bell, I think it was Bell Helmets that did Michael Schumacher's helmet. And I think he was one of the first ones to push for the helmet to be made smaller. But it's one of those sort of situations where the helmet manufacturers have a huge program of their own to listen to the drivers and to listen to the complaints of the engineers and the designers, and then try to come up with solutions to it. But as far as a team taking on the responsibility for the helmet, I don't think that's really ever been done.
Well, it's certainly a fascinating topic, and we'll hear that in the interview in a moment. Let's move on to our interview now with Bell Helmet's CEO, Stephane Cohen. As he explains, he's been involved with Bell since 1986 and has a vast amount of knowledge about the current state of helmet technology, the past development, and what might lie in the future. Bell Helmets, of course, is well known to anyone who has ever raced. I've been a customer of Bell Helmets in the past, and so have many in motorsport. Bell has been producing helmets since 1954 and is the biggest player in this sector. It also supplies helmets to 13 F1 drivers, including the Ferrari, McLaren, Mercedes, Alpine and Williams drivers, which tells you everything you need to know about the quality of their products. So here's my interview with Stephane Cohen. I'm joined by Stephane Cohen, the CEO of Bell Helmets. Perhaps you could tell us a little bit about yourself first, because you've got an interesting history, not only a very long history with Bell, but also a driver yourself.
Yeah, like many people in this sport and this industry, I started racing go-karts when I was a kid. And then I raced a little bit in single-seater, Formula Ford, also Opel Lotus, as it was called at the time, and then touring and GTs for a while, and all this in parallel with a business career that has always been linked to the motorsport industry, starting as an importer for Bell Helmets and ultimately buying the business.
And a very successful business it is too. I imagine most drivers who've had much of a career have used a Bell helmet at some point. I certainly have back in my amateur racing days. But obviously Bell has, well, the majority of the grid, in fact, I think 13 if I've added up correctly, so plenty of big name drivers. But obviously from the outside, helmets can look very steady state, can't they? They look much the same from a distance as they did 30 years ago, but they're constantly evolving. So perhaps you can give us an idea of the kind of spec of a current generation Formula One helmet in terms of weight, the structure, the materials used.
Yeah, the current helmets are obviously state of the art. It's important to realize that the safety standards that we have for helmets in Formula One are in fact the most advanced for any type of helmet in the world in terms of the absorption of energy generated by impact. These helmets are absolutely fantastic, you know. So in terms of material, we use the latest generations of carbon fiber, probably very similar to what you find in many of the Formula One cars. We use energy absorbing material inside the shell, which are some sort of expanded polystyrene, but say in the case of Bell Racing helmet, a very specific type that it took us like probably 5 or 7 years to develop it, that really meets the specific needs of automobile racing helmets. Because as you can probably easily imagine, for example, a motorcycle helmet, the kind of accident you can have with a motorcycle helmet is very different than what you can experience in a race car. And therefore, if you want to optimize everything, you need really to use material or to develop material and structures that are optimized for automobile racing. And that's what we do nowadays.
And in terms of that structure, if I was to take a cross-section of the helmet, how much carbon fibre layer, how big would the carbon fibre outer layer be roughly? It doesn't have to be precise. But
well, the shell thickness varies from 3 to 12 or 14 millimeters in the forehead area. It's mainly indeed carbon fiber, and it's also sometimes a little bit of aramid fiber. People know the brand name Kevlar, which is usually associated with ballistic properties. And again, in all these materials, you have very simple and cheap and affordable ones, and you have state-of-the-art and unfortunately more expensive products. For a Formula One helmet, obviously the price is not a concern, so we go for the highest level of performance that is available according to what we need in different areas of the helmet. Obviously the front of the helmet is the most exposed area. You remember a few years ago we were running what was called visor panels. That was this piece of Xylon, which is a type of aramid fiber that was glued on top of the visor to add an extra protection in that area of the helmet. Now all this is integrated into the shell. But as I said, the most advanced material, variable thickness depending of the area, frontal area a bit more, I will say, resistant, very simply, compared to the rear of the helmet, for example. And then do not forget the incredible work that was done by FIA, because it's not just a helmet, it's a system. If you look at the headrests and the liner of the helmet are designed, I would say, in conjunction. The densities that are used for the headrests are such that when they have to absorb energy at the same time, the liner inside the helmet will also be absorbing, and all this works in conjunction. So this is thanks to the great work that has been done by the FIA and the FIA safety engineers.
And this is astonishing, the level of detail that's gone into there. As you say, it's about the interactions. And obviously that's become a much bigger deal over the past, well, it's 30 years probably now since we started to get the higher cockpit sides and the surround. So that's obviously quite a mature science in terms of understanding how to optimize that now.
Well, I want to believe that, maybe mature, but again, consistent with Bell's DNA, we keep investigating and thinking maybe a little bit out of the box. Sometimes we take unconventional approaches to develop products that are always safer and at the same time bringing a little bit more performance, whether it's by reducing the overall weight of the product or increasing driver comfort or whatever other parameter.
And obviously the astonishing thing is it's protecting the head, and it'd be very, well, I say it'd be very easy. It'd be easy just to make it a very simple, hard casing, but trying to create something that gives enough to absorb the energy and impacts, the science of that in terms of the structure of the carbon fibre and also the way you use the energy absorbing layers, I guess that's evolved pretty significantly as well in terms of minimising any potential impact, or also just the movements of the head, because obviously you cannot hit anything and a sudden stop can have a big impact on the brain. So all of these things feed into it.
Yeah, definitely. It's not just one particular material, it's a lot of interaction inside the helmet between the shell, and the construction of the shell itself is already extremely complex. There is no less than 70 or 80 different pieces in the layup of our Formula One helmet shells, and then the way this shell will interact with the liner, the energy absorbing liner. And again, the liner, you play with different densities, different mechanical properties, elasticity, plasticity, blah blah blah, and at the end, we push it extremely far. It's not just a simple piece of carbon combined with a piece of expanded polystyrene, and there you go. It's a bit more complex than that.
The thing that astonishes me about the helmets is the weight they can achieve. Now, I remember myself trying a carbon fibre helmet for the first time, and it just felt like you weren't wearing a helmet because it was such a big step from what I was used to, and that was probably 20 years ago I tried that. So now I see the figures of sort of 1.2, 1.3 kilos. Is that an accurate weight for the kind of helmets that are being used by the F1 drivers?
Yeah, I would say as far as we are concerned, we're around 1.3, 1.4. Let me tell you one thing, Ed. The weight, it's very important, but safety is more important. And it is extremely important to stay true to that philosophy of safety first. I am an ultimate competitor, so obviously I know performance is very important, driver comfort, etc. I'm the first guy to say this is paramount, but safety is above all that. So as far as we are concerned, for sure we're aiming at producing the lightest possible helmet, but we're not obsessed only by the weight, we're more obsessed by safety. And we don't want to go out and say, hey, we have the lightest helmet. I leave this to my competitor if they want.
Well, exactly, and that's the remarkable thing, that it can be so safe at that sort of weight. And in fact, in terms of the safety, I mean, I've been to the Bell factory in Bahrain, just around the corner from the circuit.
I remember that.
I've seen some of the tests that have been done, and it is incredible what they can go through. Can you give listeners a bit of an idea of just what intensity of attack these helmets could absorb?
Well, in the test lab, it's spectacular when you see it with your eyes. When you see it on TV, it's already a little bit watered down. It's not so exciting. But when you see it in live, it's quite impressive. So one of the tests is the impact test, and what we do in the impact test is that we are using different type of anvils. The two extreme being a flat anvil, which is just a flat surface, and the other extreme being an hemispherical anvil, which is a round piece of metal. And we drop the helmet. The helmet, when we drop it, is fitted with a dummy head inside which you find accelerometers to measure the force that would be transmitted to the brain. And it's done at a speed of 10 meters per second, which is about 36 kilometers per hour. When I tell you this, doesn't seem like completely crazy, right? But in fact, it's a lot of energy in such an impact, because imagine driving your car at 36 kilometers per hour into a huge concrete wall that is not going to move. I don't think you will do that very easily. So it's a very big impact. Then we have other types of tests also. We have the famous flame test. A flame at anywhere between 750 and 900 degrees centigrade for up to 30 seconds, and then the helmet has to self-extinguish. We have an example of that in real life with Romain Grosjean, right? These are very important tests. Then we have penetration test, we have ballistic test, where we have a machine that fires a pseudo suspension spring that replicates a little bit the accident we had in Massa in Hungary. When was it?
2009.
2009.
Was there for
exactly.
That one?
Yes,
very memorable for all the worst reasons.
That's already a long time ago, 2009. So we replicate that kind of accident by firing that dummy spring at no less than 250 kilometers per hour on the helmet. A lot of different tests, ultimately to try to give to the driver the best possible protection that today's science can give them.
And obviously, we haven't talked so much about the visor. That's obviously the most exposed part for the driver because of the awkward insistence on human beings to have eyes. But obviously, those are a complex technological challenge in terms of the materials. Polycarbonate material, you don't want to distort the view. You need it to be strong. So again, it just looks like a visor is a visor, doesn't it? But that must have evolved enormously.
That has evolved. Not enough. Well, we're never happy by nature. We're always looking. But if there is one area of the helmet where we are really looking to improve, it's the visor, because this remains the weaker spot of the helmet. If you look at the shape of the helmet, you can see particularly on the Bell that we have really reduced the size of the eye port to minimize the transparent area that you need in front of your eyes to see. But it's an area where we can and we are still making progresses, not only in terms of, I would say, the resistance of the visor in terms of ballistic impact, etc., but also in terms of optical qualities, where it's a round object in front of the eyes, and we need to make sure it's not distorting the vision. We have learned over the last few years by our various collaboration that it has also an influence on the performances of the driver, because after 2 hours, if their vision is slightly less comfortable, etc., it can make them a little bit slower in reaction time. So these are small things that we are looking at with some engineers specialized in optical matters, and a lot of things to do absolutely everywhere.
And there's some remarkable stuff going on in material science experimentally at the moment. So I feel like that's an area where there could be some big strides in the next, it's always 10 years, isn't it? You think everything will be magically brilliant, but there is some amazing stuff going on. So I guess that's a big thing for Bell internally, to keep an eye on the scientific literature, the research going on, in case something comes up that can be applied.
All the time in looking up all the new materials, the evolution of existing materials, because it's not always a huge breakthrough, but a few % improvement can also make a difference, you know. So yes, I hope some absolutely incredible new materials will come up sooner or later, but also this the most important and the most realistic, especially in terms of the material for the visor, is these small incremental improvement year after year, never settling for what you have today, always try to improve. Similarly to a racing team, right? They always try to improve the car. Well, for an automobile racing helmet, such as a Bell helmet, it's the same quest for more performance, more safety.
And in terms of the performance side, never a compromising safety, but if you're a Formula One team and one of your drivers comes to you and says, oh, actually, we want to look at some different change in aerodynamic characteristic, for example, obviously these helmets will go in the wind tunnel in some form and be tested from that perspective. They're sort of an established shape. But is there a little bit of incremental gains going on there? Will you customise for a top-end customer if they request it? Or does that happen often, or is it pretty much set now what you do shape-wise?
No, the shape of the helmet itself is a fairly, I will call it, neutral shape. And then you will notice a series of holes on the helmet for the ventilation, and there we can start playing with different types of air intake, depending of the drivers, depending of the car, etc., a lot of parameters. But in terms of optimization of the general package, well, you have two main areas. First of all, the driver comfort. You can imagine that if the helmet is buffeting or lifting at high speed, it's creating discomfort, to say the least, for the driver, and that's something you have to act upon. And how can you try to correct that? It's with specific spoilers that are adapted to the particular shape of the car. Then if you want to push it a little bit further, but for this you better talk to some car aerodynamicist, but the helmet is obviously, let's say, in the middle of the cockpit. Behind the cockpit is the engine cover. Behind the engine cover is the rear wing. So one can imagine that the helmet, especially the top of the helmet, has a certain influence on the airflow that will then reattach onto the engine cover, and finally most of the team will try to have the rear wing working in a manner that is as efficient as possible. So the first element of that chain, or one of the elements in that aerodynamic flow, is the helmet. So indeed, there are ways to modify the shape of the spoilers in order for the car to be a little bit more efficient. Now, it's not that simple, because the driver, from one driver to another, they have different attitude in the car. Some of them tends to drive with their head a little bit tilted forward. In cornering, some have different attitudes with their head. I mean, it's really changing. So you have to take all these parameters into consideration when you design spoilers, because what you want to avoid is that you design something in a theoretical position and then in reality it's completely different. Not easy.
How about the internal shape? And the reason I asked that is when I was doing my amateur racing, I obviously bought off-the-shelf helmets, which are still great pieces of kit. And I actually remember at one stage changing from another company actually to Bell because the other company, the shape seemed to change and I could feel it wasn't as comfortable, and the Bell one worked well. Is there an art to the internal shape? Because obviously everyone's got very slightly different head shapes. So I was wondering what part of the design process that is, if anything, or that's just me having a strangely shaped head.
We have headache with with this kind of questions, because yes, I would compare it to shoes. We all have some brands of shoes where we know will be more comfortable and some other that we dislike, and then we have a friend who tells us exactly the opposite. With helmets, it can be a little bit similar. Now, the trick is to find the generic shape that will satisfy a large number of people. It's not easy. We are always trying to improve a little bit, but for the moment I think our standard shapes are quite okay, comfortable enough for most of our clients. Now, in terms of Formula One, we have a slightly different approach where we scan the head of the drivers and then we build the interiors based on the particular head shape of the drivers. Why do we do that? To obtain a higher level of safety when possible, because you can imagine that we have inside the helmet we have the comfort padding, right? And this comfort padding is basically foam that is more or less compressed to fill the gap between the driver's head and the famous energy absorbing liner, which is a fairly rigid material inside the helmet. Now, instead of compressing foam or letting that foam expanding a lot in some areas where the foam would be very expanded, we can use actually that space to add more energy absorbing material, therefore obtaining a safer helmet in those areas, because you can compare the energy absorbing material, you can compare it to a spring of a car. And your spring, your suspension will play a role of absorbing an impact until you are bottoming. When you bottom, when your spring in a car is completely compressed, then the car becomes very nervous. In a helmet, if your liner is completely compressed, you're sending the energy into the head of the driver. So wherever we can add a little bit of material, we take that opportunity, we do it. And at the end, that gives also a slightly more customized and comfortable fit for the Formula One drivers.
And I guess that's why, of course, if your helmet takes a big hit, you should replace it.
Yeah,
definitely. Because it'll be compromised just from the way it works.
Totally. When your helmet takes a hit, the liner will be compressed. If it's a big hit, you can have serious delamination in the shell, which is absolutely normal. It's normal to see those cracks or whatever. That's part of the process of absorbing the energy of the impact. But yeah, a hit means you replace the helmet.
Is there anything else I've not touched on? Because there's always hidden aspects to these things, so it's always a worthwhile question to ask.
Well, we could talk for hours about all the small elements. There is the acoustic insulation. It's both performance and safety. The defogging of the visor in condition like we had here in Spa yesterday when it's raining cats and dogs, and all these things are extremely important related to performance and safety. And again, lots of researches in many different areas.
That's an interesting point, actually, because again, from my racing, I always remember you put the Rain-X on or something like that to do it. Is that something that you think about as well? Not so much in fogging, but in terms of clearing water off the visor if it's raining?
Sure. You're gonna look for coatings on the visor that can have similar effect as Rainix or similar products. Yes. You have to look at everything. Since we have the cameras inside the helmets, right? The onboard camera that is fitted at inside the helmet. We have also been working on anti-reflective coating to not only to improve the images that the viewer see, but also to improve driver comfort. We realized then that we could change a few things, make things better. So it's everywhere all the time. It's endless.
Well, that's the great thing with technology and anything, isn't it? There's always gains to be made. Even if you have something that looks relatively stable, it's always changing constantly under the surface.
It is. And it's very important that we keep pushing the limits all the time. I mean, again, it's very consistent with our brand ADN. We keep always looking at improving safety and performance.
And that's probably why there's so many F1 drivers that use your products.
Hopefully. I guess we're not too bad at doing that job for the moment. But we are also very aware of our competitors who are doing very good products. And it's a nice challenge, trying to stay ahead.
Well, thank you very much, Stephane, for giving us some insight into your products. And hopefully we'll see some great strides forward in the coming decades as well.
Thank you, Ed.
And now it's on to our favourite part of the podcast, and it has that status because there's genuinely nothing Gary likes to do more than help fans understand more about the technical side of F1. So we do massively appreciate your questions. If you've got a question you'd like answered, and it can be on anything, as long as it's at least tangentially technical, send it to podcasts@therace.com. That's podcasts@the-race.com, and we'll do our best to answer it. We've got 4 questions today. The first one is from Adam, who says, we're seeing cameras replace wing mirrors on road cars. Why hasn't this happened in F1 yet? Surely they're a big aero hindrance any team would happily do away with.
Well, yeah, just taking the second point of your question there, Adam, first. Everybody's got to have the rear view mirrors. So as far as being an aero hindrance, the size is defined by the regulations. So they are, the locations defined by the regulations, so they are there. So it's the same for everybody as such. So I wouldn't jump in as to try to make it the car better aerodynamically. I would jump in as trying to make it better for the driver to see what's coming up behind him. And as we know on many, many occasions, the mirrors that we have really are not adequate for that. So yes, I do 100% agree with you that a rear view camera would be of value. It's just making sure you have a position for the display to show that the driver can look at it without disturbing his view of other things that's going on, because obviously it'll be a moving scenery at least behind you that'll be coming up on the screen, on the vision, and you'll be looking forward at a moving trajectory, I suppose you might call it. So it's a difficult one to sort of know whether it would be sort of difficult for the driver to focus and register to it. But again, it shouldn't really be any different from the mirrors, other than the fact that it would show the whole back of the car rather than just 2 little slots through between the rear wing end plates and the rear tyre as such. So I'm 100% with you that with the camera technology that we have currently, something very, very reliable could be made work. We see mirrors falling off and drivers continuing. So if you had the camera and it didn't work, well, it wouldn't be any different from that. So at the end of the day, I think the cameras would be the way forward. And we're getting big changes for 2026. There's a good one to do as well, because a lot of the penalties that we see now is because drivers get in the way of other drivers that are on fast laps. I'm not saying that would eliminate that by any means, but it would put a little bit more of the responsibility back on the driver to not just rely on his engineer telling him that somebody's coming up behind. The two would still have to work in harmony, but it might just put a little bit more of the reality back to the driver to make sure that he had to keep an eye behind him when he's on a slower lap.
There has been a little bit of work done to look into this. I think it's an idea that, as you've said, the idea is good, but finding something that has the right sort of screen, the right brightness and resolution, that's in the right place to be looked at in the same glancing way, and all those things, the little details are the big challenge. There probably will be a way of doing it, and maybe even down the line there'll be a way of doing it with, I don't know, some kind of heads-up display in the visor or something like that. Who knows? But it's that little devil is in the detail thing. The tech's all there, but just finding it so it's driver friendly. I'm sure there's a way to work it out. They just haven't quite got to that point yet. Question 2 comes from Justice, who says, I've heard it repeated often that Mercedes is expected to have an advantage going into 2026 on the basis of their new engine. It's come up as an argument in favour of Verstappen changing teams, for example. However, I've never heard an explanation for why this is almost taken as a given. Where does this expectation come from? Is it just based on their success with the last engine cycle, or is there already some actual data available to support it? If it's just based on Mercedes' own statements, why is that seen as reliable, and how could they know what performance to expect from their competitors? Relatedly, will engine suppliers already be far enough along in the development process that their level of relative performance is basically locked in more than a year before the new engine's debut?
The first thing to say there is never believe everything you read or hear, I suppose. So I'm agreeing with you here, Justice. I think it's Justice, yeah. The fact that their original 2014 engine was so successful, in reality has nothing to do with the current or the 2026 engine, because the manpower has changed dramatically. The engineers, the head of engineering, all of that's moved on. It's they're different people, so it's a whole different deal. The technology is still there, but then the technology is there for all of the companies that are building engines, Ferrari, Honda, and Mercedes. So it's one of those sort of situations where I think it's easy to talk a lot about it. I am sure they'll be putting a lot into it, and I know that for 2014 they did a great job, but it's a different deal all this time coming into 2026, because there's a lot of experience around now in that technology. So the big area really is that currently with the current engines, you have the MGUH, which is driven by the turbo, and creates its own electrical output to charge the batteries up or to use directly to power the car going forward. And the turbo development and that has gone together as a package. The two of those are they work hand in hand. So at the end of the day, you say that with the MGUH disappearing, the turbo will become a different beast. And the turbo control, really, as far as boost pressure is concerned, is down to fuel flow, because you can't produce power without fuel, and so there's no point in having high boost pressures because you don't have the fuel to go with that volume of oxygen you're putting into it. So at the end of the day, there is new stuff for 2026 coming in that you could trip up on, but the technology of the current engines will still, a lot of it will slide across. So I'm not sure where all these rumours come from that Mercedes have the best engine, because again, probably the only one that has got a package of the detail of the development direction at the moment is the FIA. And if they are spreading rumours about that, then they shouldn't be, because they would be keeping an eye on it just to make sure the regulations are going to work and that everybody is content that they're going in the right direction with it. But they shouldn't be spreading any rumours about any individual engine manufacturer's performance, because that would really be against the spirit of being the governing body.
Yeah, I think because there is that ongoing reporting and communication, there's perhaps a little bit of it comes from that sort of thing. And obviously people move between organisations and they have snapshots of ideas, but nobody has got the full picture, because even if you're getting data to the FIA, that's your own self-declared data. It'll be certain parameters, but the overall performance of your power unit package will be a confluence of all the factors. So any indication of how people are doing will be gentle at this stage. I do think when it comes to Mercedes versus Red Bull, there's a little bit of an extra dimension, because Red Bull Powertrains is a new operation and now it's brilliantly equipped. There are outstanding people there, but you could make a case that logically, given it's a less well-established organisation, it might be a bit more likely they might give a tiny bit away compared to an established one like Mercedes and some of the others. But that's not based in anything other than just conjecture and a bit of reason. But the part of the question about how much the development process is along, the die will be in many ways cast, won't it? Because they had 3 years to develop these engines, and the cost cap for the engines works in such a way that you've got an amount to spend each year, so you can't catch up as such. It's a fairly linear process in terms of relative spending between them. So although it's probably not right to say that how competitive they are is completely set, with the lead times on engines, some of the parts, they're literally baking for months, aren't they, in terms of making them. So it is locked in quite early how good they'll be. So they're already tending towards that, and then there'll come a point, probably some point, certainly by the middle of next year, it'll be pretty much set, won't it? And it'll be minor gains will be made in terms of the software and a way of operation and little fixes rather than the hardware, I guess. Yeah,
it will be. The hardware takes a lot of time. But again, from my understanding of the regulations from the current engine to the new one, it's not as though it's, a different engine altogether. It's just more or less the same package, with a few the dotting the I's and crossing the T's on a few little areas, and as I say, the MGUH disappearing. So I'm not sure that anybody's starting from nothing again. That's I suppose what I'm saying. It's the crank detail, the conrods, the pistons, all that stuff, the combustion chamber, all the knowledge of the pre-combustion, etc. Blah blah blah. All that stuff will probably carry through to some extent. It's not like you're reinventing the wheel, I suppose. So I don't know. As I say, it's just one of those sort of situations where I think Mercedes are pretty good at selling themselves in their own little way. They definitely came out with the best engine package in 2014. And there's no reason why they shouldn't believe that they'll have the best engine package for 2026. But, we've seen that with the trip up with the new regulations with the cars for 2022 when the ground effect cars came in. They dominated up to that point in time, but yet a regulation changed and suddenly they've tripped up. And, that can happen with the power unit just as easily.
Yeah, and very much the competition element of these engines is meant to be the electrical side. The regs in terms of the V6 itself are trying to be quite tight, almost make it a non-competition element. So it'll all be in the energy recovery side, which, as you say, they've been dealing with for quite a long time, but it is significantly beefed up in that 50-50 split. The next question comes from Kieran, who says, "My name is Kieran and I'm an Irish lad living in Canada. Needless to say, I'm a big fan of Gary and an avid listener of your podcast. I'm a machinist by trade and I have a deep understanding of how mechanical parts fit and work together. But there is one topic from the early 2000s era of Formula One that has always intrigued me. I'm particularly curious about the frequent engine failures that were so common during that period. From a technical standpoint, I would like to understand whether these failures were primarily due to parts overheating and breaking, or if there were significant issues from a material standpoint. As someone who works closely with machining and the materials used in various components, I'm eager to gain more insight into the factors that contributed to these engine failures. Were the materials used at the time not as advanced as today's standards leading to these frequent breakdowns? Or were there other contributing factors such as design limitations, manufacturing flaws, or the extreme conditions under which these engines operated? It's just interesting as we're in an era now when engine failures are so rare. Thank you for your time and for producing such an engaging and informative podcast. I look forward to your response."
Well, Kieran, Irish lad living in Canada, well done, and I hope you're enjoying yourself out there. The latter part of your question sort of sums it all up, I suppose, where you say about material advancement and design limitations, manufacturing flaws. All of that really comes into it because the knowledge increase in materials and material application has developed dramatically over the last, you're talking 20 odd years. Not only that, even just the machines that you machine the componentry on has developed dramatically. So you can now machine much more complex componentry with much better surface finishes, much more detail. So everything's just got that step better. And the reality of it is they're working just as hard. But right now, there are regulations that have come into the Formula One, where it's the main, for example, the main bearings, the size of the main bearing, the journal on the crank, the width of the journal on the crank, the con rods. There's many regulations that have come in that didn't exist in the later 90s or early 2000s. And the fact, in those days we were looking at also running, engines at 20,000 RPM. We're nowhere near that now. So everything has changed dramatically. For example, even the gears, we used to have, hundreds of different gear ratios. And the gears were, maybe, 10 millimeters, 11 millimeters wide. Just because you were looking for weight all the time, taking the weight down. Now the gear sizes are defined, the gear shaft centers are defined by the FIA. So I'm just taking your engine failure thing into the gearbox. We don't see gearbox failures as often as we used to, and only because the regulations have changed to reduce the expense to the teams of not being able to push the limits anymore. And again, the engine's the same. The regulations have changed, so they've got yourself in a position where you can't push the limits anymore. It's a practical solution, but it does mean engineering-wise, the real clever people out there aren't able to exploit the regulations because the regulations, they curtail your activities. So reliability has become so much better, and I think that's good. But I think it's still the challenge of taking away that engineering challenge that I always thrived on, because you wanted to push the limits on everything, but it's not there anymore. And as I say, it's just the advancement of everything, plus the fact that the FIA have come in and said, these are the materials that you can use, this is what you can do with it. The engine's got to be a certain weight. We had engines from Cosworth that were 98 kilograms, all up, developing probably 850 horsepower at the time, maybe 900 horsepower on a good day. And nowadays, the engines, I think the engine minimum weight for the engine is 135 kilograms or something. So, it's a whole different deal, to be honest. So both have gone in opposite directions, I suppose. The materials, the understanding of materials, the ability to machine the materials better. All the technology of modelling, simulation has got better and better and better. And the fact that the regulations have controlled it a lot more and reduced the actual stresses on the engines a lot more it's going to make for reliability, which is great.
I would suspect that if you had a world where engine budgets were infinite and you weren't restricted and you could do what you want and you could burn through an engine a race, that kind of thing, qualifying engines, etc., constantly pushing the limits, I would imagine that the reliability rates we'd see today, because of all those factors you've mentioned in terms of the quality, the simulation, the understanding, the reliability rates would probably still be reasonable. Not as good as they are, but provided people were making sound judgments about how hard to push it, I would imagine that collected understanding and the amount you'd spend on it would get you to a point where it's not like the worst excesses of the turbo era or something, where you'd only get a few finishes. I know it's a very, very hypothetical question. There's no way to test it, but where do you suppose it would be in that sort of world?
Well, I think it would be better, as you said, because technology moves on, understanding moves on, modelling, simulation. It's all so much better than it was 20 years ago. So at the end of the day, that will improve reliability. The fact that nowadays, we see the teams can have, 4 engines in a season to do 24 races. I saw us budgeting for 18 races. I saw us budgeting for 40 engines. So it's a massively different world. But it's for the better, for sure. I don't think 4 is maybe as many as I would like to see, because to get 4 engines to do all the miles that you've got to do in the season, it means there's 10 or 15 of those engines that are going to run flat out on a dyno, doing mileage simulation on a transient dyno. So it's all stuff again that we the viewer don't see. It's all happening in the background, but we the viewer don't see it and don't understand it. So there's a balance there somewhere between the amount of engines you can use, which would, help. I think would help the formula instead of everybody running potentially into engine penalties. It would help the formula, and it really wouldn't cost any more. Somehow along the line, the budget, the engine budget cap should cover all that stuff. But at least, let's not have lots of grid penalties because of engine requirements. Whenever those engines are actually doing the mileage on a transient test bench. So yeah, reliability is everything. I mean, reliability is what makes the racing. So let's not throw away the reliability that we've got today because it's great to see it. But also let's not just throw penalties in there where people, just need that little bit extra.
Let's move on to our final question now, which comes from A. Rollinson, who says, at the 2003 Hungarian Grand Prix during FP2, Ralph Furman's Jordan had a huge shunt approaching turn 4 after the rear wing flew off. You were back at Jordan then, so A, what goes through your mind when you see one of your own cars have a crash like that? B, what went wrong in that specific instance? And C, is component failure a constant worry?
It used to be a constant worry, yes. Again, going back to that last question about engine reliability and test benches, it's the same now for all this the componentry, wings, suspension, etc. The teams have so sophisticated tools for loading all those components up and actually testing them to a great degree. We had the same at Jordan, but we had a very minimal amount of it. We would only do it when we needed to, and obviously Ralph's rear wing was a situation where the minute you get back to the factory, you have to look at it all and make sure that it should be okay, I suppose is the best way of putting it. We had 2 failures with Ralph that year. One in Brazil when the front wishbone broke, and it's probably easier for me to explain that one because we with the other car we went on to win the race, which was a bit lucky, but we did. But Ralph's failure on the pit straight braking for the Senna S's, the minute that happened, I was on to our chief mechanic at that time, Andrew Stevenson, who's now the sporting director at Aston Martin, to get the component mileage of Ralph's wishbones and Fisichella's wishbones. And Fisichella's wishbones had done like 3,000 kilometres, whereas the 2 wishbones on Ralph's car were brand new. So immediately, you can't relax and say, oh, that's okay then. But immediately I sort of thought, well, it must be an assembly problem because they're brand new. It shouldn't happen, but Ralph's wishbones were brand new, and Fisichella's had obviously been through a lot of miles on the car, in 3,000 kilometres or something, plus the fact they would have been tested at the factory a couple of times for load to displacement tests that we used to do. So you relax a little bit thinking it has to be an assembly problem, and thankfully in that case it was. It shouldn't have happened, but something wasn't done correctly when they fitted the titanium outboard end into the carbon wishbone. Going back to Ralph's rear wing failure in Hungary, yes, that was a bit of a shock. We couldn't, obviously it's very difficult after you've got something that's in bits to analyse it. It's a bit like an airplane accident. But whenever we did look at it closely, it looked like it was the end diaphragm that was in the wing. The wing is carbon fibre. The diaphragm is a machined titanium component, and it's all tapered, and it goes into the inside and then gets pulled into position and bonded and fastened into position. But on Ralph's car, it looked like it. To be honest, it didn't fit correctly, so the glue line was very poor. But you've got another car that's going to race the next day, so you want to do something with it. So we, for the cars that were racing the next day, we beefed it all up a bit, put a few more mechanical fixings in it, and it was okay. But it's one of those sort of situations. So some of these failures happen because of assembly not being correct, and some of them happen just because of life. But you shouldn't have any of these failures. You should have your systems should find out about these problems before they become a problem on the track. But that's again, that's time, it's money, it's machinery, it's manpower. You're talking now about a team at Jordan at that point in time that was probably 150 people, and now you're talking about teams that are 850 to 1,000. So there's a lot more people to do analysis, to look, to do tests, to do whatever they need to do to prove these componentry before they do go in the car. But you still get it. I think not that long ago, Toro Rosso, well, a few years ago now, I suppose, but Toro Rosso, I think they were called Toro Rosso at that point in time, whenever one of their drivers hit the brake pedal at the first corner in Australia, I think it was, and both front suspensions just wiped themselves out. And that, again, can be down to a manufacturing problem. But you've got to be very careful with it. And it does, when I was doing it, it eats at your mind all the time. When the car's running, to be honest, I didn't like to see my cars running because I didn't want to see something happening that might be not supposed to happen. But it's a whole different world right now.
I guess that must feel like quite a big sense of responsibility when you're the person who, particularly when it's a car you've designed as well. Because obviously you design many racing cars, both Formula One and elsewhere. And I know your car's generally had a pretty good safety record during your time. I think the only one that did go wrong was nothing to do with the car. There was one in the US, wasn't there? I seem to dimly remember that was more safety, external safety, let's say.
Yeah, I mean, you'll always get these accidents, but you can go back to Imola, I think 1994. It was a tragic weekend, but we had Rubens Barrichello on the Friday crash coming into the last chicane, and he had a massive accident. He hit a curb, and it threw the car up in the air, and it wasn't through any reliability issue, but it's just that I thought about it that time. Here I am, I'm creating this thing for these guys to drive, these young guys coming in to risk their life in, and his accident, it was a big accident. But you sort of say, well, he got out of it. But you do think in your own mind, is this something I really want to do? But then the next day on the Saturday, Roland Ratzenberger was killed, and then Ayrton Senna on the Sunday. Both huge accidents, both people who didn't deserve to lose their life, but they did. And at that point in time, I did think to myself, well, if the drivers don't drive a car that I've created, they'll drive a car that somebody else has created. And I know that during my period, I put up 101% into safety. It was everything that I stood for was the fact that the cars need to be safe. We all make mistakes. We all get things wrong. And I did on a few occasions. But at the end of the day, so did others. So, that was one of the reasons why I continued. I thought, well, maybe they don't put as much into safety as I would do. So the drivers will still go off and race them. And that's the risk you take in life. It's just, you have to live with it. But living with it, whenever you're looking at a car doing 60, 70 laps of a Grand Prix, and jumping over curbs and banging wheels with each other and all that sort of stuff. Well, sometimes it's difficult to live with it because they're not doing what they should do with your product. They're driving the wheels off it. But the car should be built for that, and that's what we're seeing nowadays. The cars, there's so much more analysis and simulation goes in every component on the cars. That's why the reliability has got so much better. Both, engine, gearbox, chassis, suspension, braking systems, everything is just working so much better than it used to.
No, which is absolutely for the better, given how rare such serious accidents are. Well, there were 4 great questions there, so thanks very much for those. And remember, if you have a question to ask about F1 tech, both ancient and modern, then send it to podcasts@therace.com. And don't forget the hyphen if you're sending something in. Thanks very much for listening. We'll be back ahead of the resumption of the season at the Dutch Grand Prix later this month, so stay with us for more from Gary.
The Athletic.